All right, so this is part 2 of chapter 7. So we're talking about enzyme-substrate interactions. So remember, the enzyme is the enzyme, and then the substrates are basically the molecules that are interacting with the enzyme. And the enzyme is going to cause that molecule to either be formed and make a new molecule, like two different pieces are going to be bound together by the enzyme and make a single newer molecule, or the enzyme will bind to a single molecule that'll be broken down into two. So a temporary enzyme substrate union, so they must attach at a specific part on the enzyme called the active site. Okay, you might be asked about this. So enzymes have active sites, and that is where the union of the substrate and the enzyme occurs. So the fit is specific, described as a lock and key. So only a specific substrate will fit into that enzyme active site. The bond that's formed, it's really weak, very easily reversible as far as the bond between the substrate and the enzyme. So it's basically, I, I mentally, I think of it as like it touches, it does its thing, and then it lets go. Because chemistry is not my strong suit, but when you start talking about certain bonds and whatnot, but so once the enzyme substrate complex is formed, the designated reaction occurs on the substrate, often with the aid of that cofactor we mentioned earlier, the helper of the enzyme. So some sort of product is formed and then released. The enzymes then move on and do this again and again to other substrate molecules. So this is an illustration of that. So here we have our enzyme. And it's actually not showing any kind of cofactor here, but just for illustrative purposes, you have two substrates here. Okay, you have this one that kind of looks like a thumbtack, and then this one that kind of has like a fork on the end. And this enzyme is very specific to the thumbtack shape. So this one isn't going to be able to bind with the enzyme, but this one is. And so it does. And when that happens, whoops, my mouse isn't working, it boinks apart, right? It breaks apart. And then this enzyme will go along and make itself available for other substrates like this to be able to break it down into these two pieces. So in talking about how we can relate to it, we have enzymes in our body that will break down things like lactose, right? If we have an issue with certain enzymes, if we don't have certain enzymes that breaks down lactose, we have problems breaking it down, therefore digesting it, and it can cause some problems, some side effects from not being able to digest lactose very well. So these enzymes, these are proteins. Okay, enzymes are proteins. They're very important when it comes to digesting things and chemical reactions in the body and catabolism as a whole. All right, so a little bit more about cofactors. The need of microorganisms for trace elements arises from their roles as cofactors for enzymes, meaning the trace elements act as cofactors for enzymes. And the same thing with us. We need certain trace elements in our body in order for our body to work properly. Things like iron and copper and magnesium and manganese. Zinc, cobalt, selenium, all these things are needed by microorganisms, and we need other things as humans, we need other types of trace elements as well, but these are just ones that are just mentioned here for in relation to microorganisms. So these all act as helpers to enzymes. Enzymes are going to work much better, more efficiently with the help of these cofactors. So cofactors participate in precise functions between the enzyme and the substrate, help to bring the active site and the substrate closer together, which I can't really explain how that really works, but that's what they're saying that they do. Participate directly in chemical reactions with the enzyme and substrate complex. So these cofactors, these helpers, such as iron, copper, magnesium, manganese, zinc, cobalt, selenium, and others, are really important in these chemical reactions, specifically with the enzymes that are, doing their job, either breaking down or building things. Okay, so we just talked about cofactors. Now we're talking about coenzymes, two different things, although coenzymes are a type of a cofactor. The easiest thing for me to remember is that vitamins are coenzymes. So when you think of coenzyme, you should think of vitamins. When you think of cofactors, just generally, the general statement of cofactors, think of metal ions. Okay, that's the best way to kind of separate those two. Cofactors, metal ions, coenzymes, vitamins. So again, these, similarly, in the same fashion, they help out enzymes in the process of doing what they do. General function is to remove a chemical group from one substrate molecule and add it to another substrate molecule. I'm not going to get super excited about that, but just make sure you can associate vitamins with coenzymes and metal ions with the cofactors. So probably somewhere along the line you've recognized that if something ends in ASE, it's probably an enzyme. They're classified and named according to the characteristics such as the site of the action, the type of action, and the substrate. Prefix or stem word derived from certain characteristic, usually the substrate acted upon, type of reaction, catalyzed, or both. So common names in biochemical actions are carbohydrates, protease, lipase, polymerase. Okay, like protease is an enzyme that acts on proteins. Get that? Proteins. And then lipase is an enzyme that acts on lipids, right? Carbohydrates is an enzyme that acts on certain carbohydrates. So that's how, there might be a question or two, probably in the SMART book on this, but I don't get super excited about that. All right, so let me see how far I have to go here. So I'm gonna stop here and then pick up on the different types of specific jobs of enzymes. So that'll be part 3.